All right,
All right,
so
sir. Hello.
well, hello. Uh, so I got this question that it's gonna involve two lists, and you're going to have to they're gonna be ordered, and you have to merge them into one ordered list. Okay,
Okay.
so
Does this use is it like are they linked list or what kind of list are they?
yeah, so it's our own struct, and it has um okay, it's got your one
Your head
data,
pointer?
or you have your value that's an int, and you have a pointer to another list node that is uh yeah.
Okay, so as far as I understand, I have two linked lists. They're already ordered, and then I have to return a third linked list. I have to return the head to a third linked list that combined the two lists, and they are now ordered too.
Yeah,
Okay. All
exactly.
right. So in that case, I'm gonna start with just this template, and I'm assuming the struct. I guess it's not important what variables I use because we'll know what we're each other talking about. But I'll return a list node pointer, which I'll be returning the head to the new list, and call this merge list. And I would take in uh to be head of list one. I'll just say L1.
uh,
And I'll take in the head of list two, and I'll say it's L2.
are you sharing your screen? Just want
Oh,
to
no, I'm
make
not.
sure.
Let me,
I know you're good.
my bad.
No, I got all that so far though.
Um, do we have shared screen allowed?
Oh, here, let me see. It's, there we go. Here, I think it should be good now. Or advanced sharing options. All participants. Yeah, yeah, it should be good.
There it is. Okay. All right, you can see my screen now, correct?
Yes.
All right. All right, I'm gonna write down a couple notes. I have a paper, pen and paper in front of me, so using to articulate. And do the lists contain any duplicates?
They uh, it's, and yes, they can include duplicates.
Okay. But I don't have to remove them, right?
No.
Okay. Hmm. In that case, I think I'm going to make a list node pointer head one pointing to L L1 list node pointer head two pointing to the head of L2. I'm gonna do a while loop while head one does not equal null pointer and head two does not equal null.
Okay.
Okay.
So, and what is the
Yeah.
purpose of head one and head two? What are you doing here?
Honestly, hold on.
Not that
Because
I'm
I don't want to
questioning anything, just
I don't want to why I'm using head one and head two is because I don't want to change what these pointers point to. So I'm just using these as a way to traverse them
okay. And then
without changing these like pointer addresses.
gotcha.
And hmm, so I had one. Yeah, there. So now I'm gonna do if head one val is less than head two value, figuring out what should be the first spot on the list. I don't know how strict they are with how strict we are with brackets, if I have to like be super proper about that, or
Oh,
if I use tabs.
I think it'll be fine if you use
Oh,
tabs.
wait a minute. If head one val is less than head two val, then I'm gonna head one's gonna append to the start of the list. So I might need to make a third for the new list. Hmm. Why am I blanking right
Now this looks good so far. I,
now? Okay, I'm just kind
I
of blanking. I'm blanking on like inserting it to a new like creating a third list, like third linked list value, combining the two. Because I don't have to actually figure out how to do this. I'm just gonna write out the conditionals else if I'm just gonna write a third else if. So I'm just gonna draw something out real fast. All right, if head one value is less than head two.
and I guess you could also pull up like a paint uh document if you wanted to
Oh, what?
actually like a MS Paint, like if you want to draw
Oh
out any
yeah, I
like
see what you're
logic or
saying.
anything. But or
This
like
is good right here.
yeah, just to show it's
So if head one value is less than head two, if the first value in that first list is less than the first value in the second list, then I'm gonna reassign the pointer in for the first head to point to this. Wait, hold on. But what about? Hold on, make sure. Hmm. I think I need a second while, two other while
So
loops to see if while
yeah,
if this is an and. Would this need to be an or
so
and then I do a while? Would
well,
this need to
okay.
be and then I think what I'm thinking is that these go over.
Yeah, because with the and before, I think uh it might not get to all the
Yeah. So while head one does not equal. So what I'm thinking here is that when while one of them's not null, if there's still some left in each list, I'll go through head one, and while I'm at head one, I'm gonna go through like whatever head two is pointing at, and if head one is less than head two, then head one next will point to two. But if head one is greater than two,
would
then
you hmm,
we need sign.
hmm, I believe you're
Yeah,
assigning the next pointer to so head two, I think we need wait. Okay, so head two is the pointer to the like okay, when you say head one, arrow next equals head
yeah.
two.
As far as I'm concerned, I don't need that new list node right now. It's what I'm trying to do is just go through each list and then rearrange their pointers. So it's kind of more like combining the lists as opposed to
Okay,
creating a
yeah,
whole
yeah.
new one.
Yeah, I'm seeing it now. Okay. Gotcha. So
And then head equals Head next. Okay, so while head one is not null, I guess I really don't need this either. Because this will just happen in this conditional. If head two val is less than, and this could also be condensed. All right, so I'm just gonna review. Okay, so okay, so I have two head pointers, one pointing to the beginning of each list node. While one of them is not null, I'm gonna see which head pointer isn't null, and then compare it to whatever head two is pointing at, and if it's less than or equal to, then the head one next will then point to head two. So I'm gonna draw this out too. Okay.
And
Yeah.
outside of that that while loop is that the head is should be head one, right? I believe like right below
Oh
that.
yeah.
Yeah. So okay, yeah. So this all looks good. Because yeah.
Okay, so then okay, yeah, so I got head one isn't null. I also need to make sure this, yeah, this should be in the while loop. Okay. Hmm. Yeah, what's- I'm gonna make an else branch here. If head two or if head one val is becomes greater than head two, I'm gonna break out of this while loop so it doesn't run through the whole time until it hits null. Same thing here.
Well, okay, so if the first while loop or the first nested while loop runs all the way through, um,
So basically what I wanted
what,
to do is I want this to run until head one value is bigger than the head two value. In that case, then yeah, if until it's bigger than the head two value, then I might not even, what I could do is I could just move both. I just move head two be head two dash next, then it would erase even needing this.
Man, I think is this all you need? Wait.
And then if I were, yeah, I think after, if I just return head one, wait, no, what I need is I think this is where I need a new list node pointer. But then, okay, yeah,
Yeah,
no.
because if you
So basically, this is going to catch the value that this is initially right
yeah,
here. And then I'm taking this list node one and I'm inserting all the values from list node two into list node one. And this return head is essentially pointing at it. And then if I return, well, I guess that's a bad image. Let me just read through this, make sure I'm seeing it right. Not being in an IDE is actually like so
yeah,
much.
I can understand. That. Then are you
All
good
right,
if I start like typing this up in
uh-huh.
leak code to see if this works? Like and like fixing the like any I don't know, like syntax errors or anything that might be in here.
Yeah, I think I found one edge case that I'm missing is if the beginning, if head one points to a value that's bigger than what head two initially points to, then this will never it will never catch that. So hold on. I might need to. No, I actually don't. I actually don't need to break out of it because I realized I need because if this doesn't activate or if this doesn't like trigger, if this conditional doesn't return true, then it needs to hit this to go to the next one to see if that one's true. If it hits the else statement, then it'll just break out the entire loop. So I did not mean to do that. So if, let's try that again. All right, so in the edge case that head one is a value greater than head two, this will never return true. So then head two value is less than head one value. Then head two next will then point to head one. This node will get a head two equals head two. Hmm. Two, two val is less than one val. That's the one. Okay, I figured out I have another issue in this code is that if I run it like this, then if I have a list that's 2, 5, 7, and the third list it has all larger numbers like 8, 9, 12, then it's not going to compare, it's only comparing what it's pointing to, it's not comparing its next values, which is an issue. So instead of that, I'm actually going to erase all that and make it so while head one val is less than head two. How much time do I have?
I was trying to figure that out. I can't see how long the recording has been. Um,
I'll just keep going.
I'm guessing like we're at like 11 or 12 minutes, maybe.
Okay.
I don't know though.
Okay, so while one value is less than head two value.
It says at least 25 minutes. So
Yeah.
I think
Head one.
so then So in the first while
Yeah.
loop, um, do you would you have to do any moving of uh head two or like
So yeah, no, what I'm thinking is I still need to like move them to where like after this loop ends, then head one will equal head one next. But hold on, I think I need to do that before. I need to save the value. Well, because if head one becomes head one dot next, then it'll just point to a head two. It'll point in something in a second list, so that's an issue. So this points to head one dot next. This is 10. Okay.
so how how can you prevent uh inserting head two elements into head one without
Yeah, no, I definitely hold on. All
like
right, so hmm, I'm just losing. You have any hints lined up?
yeah, so yeah. I think the I think the easiest way to start this, I think, is by going with the most straightforward solution. So, and then like we can make it more like more efficient like after that. But like you started out with like wanting to create a new list, and then just adding in the elements from each list as like you compare, so like you can
Mhm.
and I think that's a good way to do it. It might like take up more memory than by trying to do it uh like
Yeah,
without making any new lists, but I think it's the most straightforward approach. Um, so because I believe if you were doing it how you were doing it before, you would have to create new nodes and then copy the values from those
yeah.
nodes before.
Okay. All right. So then,
And
All right, so
I think
in this case scenario, then this or hmm. What I'm wondering right now is like doing this without accidentally running into like a segmentation fault by like because if I make this an and, I don't want to make this an and because if I make this an and, then like head one could still have lit or elements that need to be like traversed, but then head two might hit null, so it wouldn't run through this loop anymore.
um well yeah, wait, this while loop would go until both are
Yeah.
done,
Well,
which is
yeah, I would wait until
yeah.
both are, but the thing is, okay, because then I can't access it. Do that. I can't create a new node.
No, I think you can because here like we're given the definition of the linked list like structure
Yeah, the
and it
issue is
has
though, if I create a new one every time, then how I'm gonna have issues like linking them together. And also,
yeah.
I just
So I
don't know.
guess you could either well you could create new nodes or you could like store the values or like the integer values that are in them and then just like replace the ones in them and then save it for the I'm having a hard time like articulating it, but like you like you save the integer value, replace it, and then compare that saved one
Mhm.
again or something along the lines of that. I have to like write it out to figure that out, but I think that makes sense.
Do you know what our time is?
Uh, I don't think we have to worry about going over. Um, but I don't know. Here, I can see what time we ended our Discord call. Let's see what that means. So it started at like 2:40. I'd say like 2:55 is when we wait. No, that didn't seem right. No. I think we did we start at 3?
Um, it's 3:34 now. Um,
Yeah, I think like 20 to 30 minutes, maybe. Because our call on Discord ended at like 2:51. And then we started the recording at like 2:55, maybe. I'm not sure. Mhm. So, yeah, what do you want to do from here?
so, all right. I'm trying to just rethink it because
All right,
I'm just
like,
like, I got myself like into a line. Okay. Let's call it dummy node. This is it's going to point to like the final. We're not going to point to this final. It's going to become the new list. Okay, list. Yes. Wow. I actually don't do these at all. Okay, here just all right. So while they're not, we're just gonna keep these each other. So I just made a dummy node and then a current that's gonna traverse each one. Current next, if L1 is less than current 2, then current next is L1, else then current next will be L2, only moving these forward when their value was inserted into the current list.
And uh, so what is the first element of current? Is that
Um, oh yeah. Well, it points to this dumb, that's what it's pointing. This is kind of acting as like, okay, so I kind of, all right, I see what I could do. At the end, instead of returning dummy node, I could just return dummy, dummy node next. So that value gets erased. It kind of just, the reason I made this is just to have something to point it to. A traversal method, like a third party. Um, this is gonna check the edge cases if head 2 is null, but then L or wait, is it if L2 equals null, but L1 doesn't, then it's gonna check here. What I'll do here is I'll attach Yeah, I also need to move current though. So I'll do that down. Wait, and also this should be out, should actually be outside. Okay, the only concern I have left now is what happens when I reach L1 null pointer, and then there's still values left in L2 that need. You know what? I know what. If there's still values left, then all those values are already going to be sorted. All I have to do is enter them into the list. So I can just do another while loop. Wow, L1.
So, in your if and else statement, would you want to have it be changing the next or the current? Because if you're, um, because like once you get out of those, you then go to the wait, hold on.
So I'm saying like if this value is less than that value, then current next equals L1. L1 moves to the next node, and then until L2 is bigger, then once L2 is bigger, then wait, hold on. Well, before that, if it's out like after this executes, then current's gonna go to current.next, and then this L1 will have moved, but this won't have. So then after that, check again.
Okay, wait, I think I see what you're saying. Okay.
And then if L2 is bigger, yeah, so then if when L2 becomes bigger, then we insert it into the current node, like current next node list. And then we restart. So then L1 will probably be less than node 2 again. If not, we keep on inserting these. Current keeps moving. That should work. I believe this. I believe all this should work. I just need to figure out the edge case of what happens when one reached null but the other didn't. And x equals L2. L2 equals L2. Next. And then this should point to the head. All right, I'm gonna draw this one last time. I think this should work though. I might. One thing I'm concerned about is if this one's not null, but L2 is null, comparing it to a null value would probably cause an issue. So I think I can make this an and statement, which is okay because so once one of them becomes null, it'll add the rest down here to keep that.
Okay. So
So then it plus. Yeah. Think I'm not seeing any issues at the moment.
yeah, well, I think
You have a solution pulled, like you have a solution written, I'm assuming.
well the solutions that like I think there's a lot of different ways to do this.
Yeah,
So
there
I can
definitely is. I know there is.
uh
But if I see well, if we look at a solution, then we could probably like decipher whether I have the right functionality, even if it's not the same code.
yeah. Okay. Uh, but no, I mean like writing it out, like this should work without like the logic's working, I think. Uh, uh like and if you like put it into like lead code or something and it didn't work, I think you could easily adjust the logic from there.
Yeah.
But like I think everything if like there are mistakes, it's like minor things. Like but yeah. And I think like what's important is getting the idea for
I
it.
think is the grading done on just the interview itself.
Yeah, I think so.
Okay, so if you want, then you could just ask me the questions, and I think we move on to you.
Yeah, I think that'd be really good. Okay, and uh I was trying to pull up these questions again. Okay. Okay. Okay, yeah. So okay. Yeah, I think like yeah, wait, so the question there, what parts can the candidate improve on regarding and all that stuff?
One thing
What we
I
talked about.
definitely say I noticed is like doing questions, like programming questions, like in this environment definitely freaked me. Like I was definitely not thinking straight. I was like, it was like it had me like over like not really knowing what to do. It had me freezing up, is what I'm looking like trying to say. I kind of froze up. It's
Yeah.
just like when you have someone like looking, I mean, obviously like we're just partners and stuff, but like that's my takeaway is like when it's an interview and they're watching you do it, like it becomes a lot harder. Like I don't think if I was doing this just on my own account that I would have had so much trouble thinking through the problem.
Yeah, I for sure get that. Because like when somebody's like watching you do it, you're like trying to do the most efficient way,
Yeah,
maybe. Or
it has
like,
me like yeah, it also has me overthinking about like what kind of code I'm writing, stuff like that.
yeah, like, yeah. And okay, so are these the questions I'm supposed to be asking you or the okay. Okay, what parts can the candidate improve on regarding the technicals? Uh okay, yeah. So uh I guess you could have like led me through your thought process a little bit more. There were some
Got you.
parts like and maybe uh like if you did have something you could like draw on to like show me, I don't know,
Yeah, because
like
like linked, like this is what like all my paper. It's just like linked lists. It's a lot of like just drawing. For me at least, I like to draw them out a lot so
yeah.
I don't lose any pointers.
Yeah. So I think like it's easier to show the ideas when like you're writing it down. So like that would help me, I think, to you know uh And then yeah, I guess like what I was saying before with like trying to find like the most brute force method first.
Yeah, and then worrying about efficiency later.
Yeah, because yeah, uh, yeah, but
Is there any other questions?
mm, mm, yeah. So oh, wait, reflect on the quality. No, I don't think so. I think all your questions were good at the beginning,
Mhm.
and yeah, I don't think there were any essential parts. It's I think that's all. Uh, yeah, yeah, I think that's
Okay.
about it.
So then here, I'll stop screen sharing and then we can move on to your part.
Okay,
So you can share the screen and I'll
okay.
go here. So yeah, you just go to like the second half of the Google Doc and I'll ask my question now.
Like just a new page.
Oh no, just like I mean, that doesn't really matter, I don't think.
Uh, yeah,
Okay.
I just a new page. All right.
So my question is going to
Oh,
be,
oh wait. Oh yeah, yeah. So we're still using this recording. Yeah.
yeah, just you record straight through, right?
Yeah, yeah. Okay. And okay.
Okay. Um, I have two questions, and the issue is for some reason I lost the first question. I lost some of the things I had written down about it. Do you mind if we do the binary tree, or it's not just the tree question?
Yeah, sure.
Okay. So in this one, you're given the root of a binary tree, and basically you want to figure out if the left subtree and the right subtree are mirrored equivalent. And this would be, I'll draw it out. I'll give you a little image. I have a whiteboard here because it'll be a lot easier
Okay,
if I
mirrored
just
equivalent
demonstrate.
as in the values being stored in them, or just
Yeah, the value stored in them, like the tree nodes are in the same spot and the value here, I'll show you what it looks like. So this, this. So we have a binary tree, and that's a one. And then these are both twos. I know my handwriting's not great. These are both twos. These on the end are both threes, and these are both fours. So to watch for is that you wouldn't like, yeah, you wouldn't, it's not symmetric, it's mirrored.
okay. I got
You
you.
see what I'm saying?
Yeah. Okay. So
And you're
okay.
gonna be given the tree node root, and it's gonna have everything normal. It's gonna have a left node, a right node, and a value, and like it could be null.
Okay. So I think what my mind first goes to is creating two separate nodes and traversing through them oppositely. So one goes to the right, one goes to the left, and you compare the nodes. Um, and if they have the same values, then you keep going. If they don't, you exit. Um,
Yeah, and you could return a Boolean for this.
okay. And I guess, but then, okay. So yeah, I would go until I get to the bottom of the tree and then go back up. Okay. Okay.
You could think about using like a different type of traversal, like a pre-order, post-order, in order. Just making sure you're whichever one you're doing, you're comparing them like mirrored, like in a mirrored way. That like they're both visiting the same route at the same time. Just make sure I don't want to give away too much info. I don't know.
Yeah.
Okay.
Okay.
So whenever you're ready, you could share your screen and start in the Google Doc.
Okay, there it is. So I'm let's start actually with I got a paint thing. Okay, so I got my tray here. Okay. Okay. Say one, two, two. That's supposed to be three. But okay, so I'm given okay, I'm just giving the root node. So and I return a bool. So it's well that. So it's I, bool. Oh, gone. And function will be called mirror something. Okay, and we got the tree node.
Yeah, I just call it tree node.
So I'm going to do, I think this thing would be created tree and tree node left side and create a right one. And then so okay. So the left one I want to do either post wait. Yeah, I want to do one of the orders on one side and one of the orders on the other side. So I go down. So hmm. Okay. Okay, so I think I would need to start at these before I start the loop.
In the mirror
Maybe.
function, you might want to write in like root right there just to know, just to clarify like the argument you're taking in. Yeah.
Okay. Um, gosh. Um, so I think and yeah, so then I want to go let me just draw this out a little bit more so I can get a better idea of when
Yeah.
goes further down. Okay. I'm right here and I want to compare these two. Go so I go right and I go left. Okay, then I go Okay. So wall. I almost. I think I would need to create a helper function maybe. Or
Yeah.
okay, so I can do that. And yeah, like I would need to create hmm, yeah, leave it. Yeah, in order and post order helper functions. Right. So
Um,
okay.
I wouldn't over if you a little hint I guess I can give you is I wouldn't overthink about doing a pre-order post order. Just think about the fact that every time you have like a mirror, you compare a right with a left and a left with a right, you know?
Yeah.
Because if you do the pre-order post order method, then you might be comparing a root node with like you might be comparing like for example a 2 with a 4
Yeah.
if it's like if it goes through wrong.
Okay. Okay. Yeah, so the thought process is like I need to create like a loop that okay, so I maybe like while these two are equal. So right, while they're equal. And that might be it. Okay. Uh okay, yeah. Let me just start with that. While uh left value. I'm just assuming that's what it's called.
Yeah.
Or uh and I think it'll only check after that runs fully, I believe. Yeah. So like I can change them. Wait, no. Yeah. Yeah. Okay, I can change them in there and then it'll fine. So okay. So if now I can move them. So if minus left, or yeah, left. I'll keep this. It's consistent. So yeah, I want to go.
Wait, could you explain to me what if left points to left?
Yeah, so yeah, I guess I could I should rename
Oh,
these.
yeah, yeah,
Yeah.
yeah.
So
See.
left, yeah, I'll do
Yeah, whenever I
branch.
name, I usually, yeah, I just write left sub for like left subtree. That
Yeah,
works too. Left branch, right branch.
that'll be yeah. Yeah, I usually do that, but no, I'm just kind of hard to
I get
remember.
it. I get it.
Uh okay. Um listen. Um it's not equal and one there, one, two. So I'm thinking, so this will run until it's there. And then,
So, Mike, do you plan on I just know every function and everything I've seen and learned about trees, you usually traverse them either using recursion or queue.
yeah, okay. And
So if I could give you the best like advice or hint I can give you right now is think about how you could use recursion.
yeah. And I was thinking about that before. And I need to create a function outside of this then.
You could do it both ways.
Okay. So what, like, okay. Hmm. Yeah. Okay. Recursion, do you mean I do recursion in the mirror function itself? Like I call,
Yeah, you could
yeah.
well you could um like
Yeah,
you could
okay.
call a
I
mirror
think
function
I can see that. Okay.
within itself. Personally, I did a helper function.
Yeah. Because if I yeah, yeah. And uh, so yeah, I think I would want to do a helper function. And okay. This is a bit harder when you're on camera.
Yeah,
So
no, I know, right?
uh okay. I want to hmm, hmm, hmm. Yeah, I think trying to make it recursive with this function seems a bit too much to think about right now. Uh, but I'm gonna try to create a function outside of this. Uh, so then what would I need to do here? I need to return root. All right, now, yeah, I got a tree node. Let's go. What do we call this? So I'm gonna need two helper functions, it seems. Okay. One for the left side, one for the right side. And
Well, couldn't you just use a helper function for both, like sides? If wouldn't it? Well,
okay, so I'm trying to think of how to do that. So I would need and then well,
think about just comparing. Think about when you have your left subtree and your right subtree, you're really just comparing two. You're just going to compare two trees. The only difference being that you compare the lefts with the rights and the rights with the lefts, as opposed to just left with left and right with right.
yeah, so I'm like for my left side, uh, hmm, Hmm. Maybe go with one function. Because what I'm thinking is like one function goes one way and the other function goes the other way to return
Hmm.
a value, and then
You compare those two values.
yeah, but
Yeah,
okay.
that might work.
Or okay, no, or I could have no. Okay, I see. So I have one function that takes in two roots and then returns a bool. Wait. Yeah. Wait. Yeah, and then I manipulate those two roots in different ways until they can't go further. Is this along the lines you're thinking? I don't know
Yeah,
if
well, yeah.
like so it'd be
You take in,
it's
you have a Boolean function with two roots, and then you traverse those two roots, comparing. Is that what you're saying?
yeah, wait, so the original yeah. So instead of just having the one root, I
You could take in the left subroot and the right
yeah,
subroot. Yeah.
okay. Uh okay. So then uh I'll name this one traversal. And is this how the function is supposed to look? Like this is what it was originally. Like with
Oh,
the
yeah.
one
Yeah. That's how it was.
okay.
Like in the leak code, you're saying, in the leak
Yeah.
code prompt? Yeah.
Uh, and then okay. So then now I gotta think of a way to make this recursive. So I want to have one go. So if okay. So if O sub goes left, R sub goes right, and those are both equal, you make them then you call the function again with
Just think
those.
about, yeah, you could think
Yeah.
about just traversing it and only worry about returning false, you know?
Yeah.
Like only if it's false does something like do you have to break it. If it's uh
Yeah.
if it's true, then it'll just keep going.
Yeah. Okay. 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 So yeah. Okay. If think. Yeah, right. Or dot yeah,
Well, don't forget to compare left sub value with right sub value themselves. You know?
wait. Oh yeah. Okay.
Like
Yeah.
watch before you skip to its left.
Yeah.
And also you got to think about null pointers too. Those edge cases.
Uh, Um, yeah, we'll worry about the null pointers a little later.
Okay.
Uh, okay, so so, so then we will do. I think we can just call this again. So, what do we want to do? We want to return. Yeah. Okay. I think we do return traversal. Uh, so left, sub, and then that'll do that, and then but then we get no, okay, so I've gotta, but that's only if they have those. Okay, so okay, so I'm trying to figure out right now when. Okay, yeah, and then okay, yeah, so yeah, this one for just checking. Just return. Okay, and if left and uh,
By the way, if two nodes equal null, they're considered equivalent. So that would return true
okay.
in the
Um,
same, if they're in the same spot.
yeah, this is more so about um
Return, yeah,
yeah,
calling it again.
calling it again. But
One thing you could think about is if you just make an if branch right in the start, asking if both are null, then you wouldn't even have to worry about it. Because if you passed in two nulls to the function, it would check in the very
okay, yeah,
first if branch.
gotcha. Like uh yeah, okay. So that'd be my base case. Or
Yeah.
like okay. Um
So if
then
they're both null, they're considered equivalent, which would return true.
yeah,
Just letting you know that constraint.
Uh, okay. If so, okay. But then, hmm. So all this would do would just go down the left and go down the right until everything's true. But now I need to check for, okay. But then, so once it got down here, it would say null pointer. And then this would go back as true. So I need to, hmm. Yeah.
In your return statement, you might you compare the left with the right, but there's another case you're missing.
Yeah, if also, so this equals this. You mean like right here?
No, we're in
Or
your return when you have your return that.
yeah, okay. And then yeah, so I'm trying to figure out where I I need to so okay, so I'm checking what do I check there? Return. So hmm, hmm, these are equal. Mhm. Okay, so then that goes back up. Oh, okay. I got it. Yeah, so I think I can just now go right. Uh, I just do the same thing. Oh wait, I don't even need.
Oh yeah, you wouldn't need to make that if branch again. You would just uh
Yeah. So uh, wait.
all right, I see like the confusion. You're
Okay,
trying
yeah.
to figure out where how you could return like both of them.
Well, okay, but so where I'm going is okay, so it goes down to here and then it'll return true. So then it'll go back up to here and then it'll no, I don't want else. I just want another if. All right. Wait, no. I don't
I
want
think
any
what
I
would
don't
help you out, I think what would help you out is to know that you could return two functions on the same return line. It's more of a syntax thing. You see what I'm saying? You could return traversal mirror left, sub right, and traversal mirror sub right, sub left.
oh yeah, like wait. Oh sub right or sub yeah, okay, so just put this here. Yeah, okay. Is this what you're saying?
Yeah, you just put them like, well, no, you couldn't do that because once it hits, well, could you do that? I'm actually not sure. I don't think you
Well,
could
well
because
okay.
once it hits that return statement, it's gonna dive into that function,
And
but
then it'll
then
return
it'll come
true
back
once.
out. Yeah, then it'll come back out and hit that. Um,
Yeah, but I'm trying to figure out. And then I think I could just do else return
what I
false.
was, but the point I was trying to make is that you just have one return and then you do traversal mirror XX and like the and symbols, traversal mirror XX on the same line.
Traversal. And wait, you can do that? Wait.
Yeah, that's what I was, it's like a weird syntax thing. And that's like what I figured out because I also ran in the same problem in my solution. And that's what I figured out is you could have uh
Okay.
call that
So,
return on two functions.
but okay, running through the logic here. Um, okay, wait. So it'll okay, we start out at 2 and 2. These are equal, so it goes to the left, goes to the left. Then it gets a null pointer, returns true. You're back up here. Then you're at your second return. Then you go right, and this one goes, well, yeah, this one is supposed to be left. But
Yeah.
I think this would do that, right? And then then we just
Those would compare the right functions. They would. Or right
then
nodes, I mean.
with this,
The only thing I'm not sure about is having a return statement right on top of itself. I don't know what, but I think it
yeah.
would work the same way. I think it would work the same way as using like an ampersand to do two functions. So I don't think it's a problem.
Well,
I'm
actually,
just not sure.
once it gets down to here, I think it'll return 0, and then all this will go away. So I think I might have to do ampersand, right? Because
It wouldn't ever return zero because it's a Boolean,
yeah,
but
I think I would have to do. I couldn't do return. I'd have to store some value and then return.
you wouldn't have to store a value. You could just return the function because it will return a Boolean. Um, but it won't return zero. It'll just return true or false. Like even if it's null, it's it'll return true or false still.
Yeah. Or like yeah, because right here, I don't know if we'll ever get to this, right?
It it would eventually. I just don't know if it'll do it in the right order as as if what I'm like compared to like the code I wrote, I'm just wondering if it'll behave the same way. It could not. I'm really not sure. I'd have to like think about it. Like it, if the return traversal was left side, right. I think it would, but I think it would cause a compiler error for having, would it?
Well,
I don't know if you could, I just don't know if you could put a return statement on top of itself like that
yeah, because
in the
as soon
same
as
if
this
conditional.
returns true, then
Once that
it
returns, yeah, it's gonna break out of that function and then hit the
yeah
return statement right under it.
yeah or
I just don't know. I just don't know if I went in like an IDE or something and wrote return return right on top of itself, if that's like
once it hits return,
syntactically.
once it returns any value, it never hits this one, right? Because
Yeah,
it exits the
that's what I'm
function.
thinking.
Yeah, so I think I have to do the ampersand. And that works. Return.
Sorry.
So you can really you just do it like this.
Yeah, just and yeah.
Okay. Hmm.
So as of right now, do you feel you're missing anything? Well,
Uh,
besides like your return in your traversal mirror, you're still missing one edge case.
Yeah, so uh, get here. Um, I think the edge case would be here, maybe. Or one. Uh, let's do. Wait, what? I'm not confirming this, but so wait, if I
The issue with that if else is if that if doesn't return true, then it's always gonna hit that else. So you wouldn't want to do an
yeah,
else. You'd want another if.
uh, so if yeah, uh, yeah. So like I think the test case, yeah, is
Oh,
if one of them's
wait,
null
I think,
pointer
are
and
you still recording? Oh, it is still recording. Okay. I just didn't know if like the recording ran out or something. So you mentioned that 45-minute thing.
yeah, no, I think
We're still recording.
yeah, yeah, because there was only when it was connected to my Gmail, I think, but I think since I'm using like the UF email, it's fine. Um, uh, yeah, so like it's the test case you're talking about, like where one's null and the other's not.
Yeah.
Okay. Um, so if else, uh, and maybe like
This'll work. You
yeah,
could just simplifying it by just you could just do if else sub equals null or if right sub equals null because it doesn't matter which one which one equals null as long as one of them does.
yeah. I was kind of just brute forcing that. I know there's some like whatever that one dude's name is, law, where okay, like okay, but yeah, this works, right? It's
This
just
works. It works. So
a
feel
little
free to
long.
yeah.
Uh, yeah, right. Because I'd have to wait. What were you saying to do? Like a nor? Oh, yeah.
Hmm?
Wait, yeah. What were you
Oh,
saying to
well,
do?
yeah, you could just do if L sub equals null or null. I mean, if L sub equals null or if right sub equals null,
Yeah.
then like it would tell you that one of them because you already know that they both don't equal null because it passed that first if statement. And
Mm,
if neither of them equal null, then it won't hit this. It would only ever hit this statement if one of them equals null. In
yeah.
that case, you know they're not equivalent.
Okay. Yeah. I got you. But Mr. Waltz. Okay. Okay. And then okay. So run through this all. Okay. Um. So if that equals that, we go here. So this runs this at the same time. I'm assuming, like through like pipelining or something like that.
I think it's through a stack.
Okay. Uh,
But I just know that one works because that's the one I did. I just didn't know if like the two return statements on top of each other would like have some unintended like functionality.
That's pretty cool to know though. Okay, so while okay, and then I can just do uh so equals okay. Return reversal. Is that
Yeah, that's
that's
it.
it? Yeah.
Yep. Good job.
Thank you, thank you.
All right. The questions. All right, so what do you think went well?
Hmm. Hmm. I think not getting I feel like I moved to different ideas pretty fast. I think get stuck on one. And like
Yeah,
your
I see
hints
what you
helped me
mean.
out. Uh like uh hmm. Yeah, like yeah, trying to figure out figuring out that I needed a helper function
Yeah, I think
and
drawing it out was probably a big help too.
yeah,
That with that app.
yeah. Yeah, I think that definitely helped. And then just like yeah, running through my ideas and seeing like why they wouldn't work and then figuring out like here figuring out that I needed a new function with two parameters that
Hmm.
just like uh yeah.
I got
Uh
you. What do you think?
that's kind of
I'll go to the next one. What do you think you could have improved on?
hmm, hmm. I know there is stuff, so I'm not
Yeah. Do you also feel like it was tougher being on camera?
yeah, definitely. Like my like
Your
having
thought process. I
yeah,
feel like you kind of get super overwhelmed.
yeah, like my mind goes like blank when I'm like and
Yeah.
like yeah, it's very hard to like because a big part of the thinking process is like running through a lot of bad ideas before it's
Yeah.
like the good ones. It's like hard to filter those out, but
I definitely felt more rushed.
yeah.
Like I had to like come up with it on the spot.
And like since you know how to do it,
Hmm.
like
Like me watching you like make the
yeah,
wrong moves or something. Yeah.
yeah, like that's cool. But hmm. I think I don't know, do you have tips?
Yeah. Honestly, I just you spoke through your process thought process pretty well, better than I did. I definitely could have improved on that. Um, honestly, hmm, not really. I don't have any tips for you aside from the part that we both could have just um solved our problem. Like, I mean, that's gonna come with it though,
Yeah.
like just getting better at the problems.
Yeah.
But no, I think other than that, it was good.
Okay. All
Good interview.
right,
Is this the
sweet.
end?
I think so. So did I stop recording
Yeah.
and then pause recording?